Hello, everybody. Good afternoon. We hope you are all enjoying your pizza. So we have the pleasure of introducing YSE's very own Professor Rao. Obviously, you all know that Biomes is really dedicated to bringing top research into the discussion forum with faculty, students, and staff. So we're really excited that you're here. And we're really excited to invite Dr. Rao. Dr. Rao's research examines the relationship between energy systems, human development, and climate change. His current focus is on investigating the household level impacts of energy transition policies in the United States and around the world. His project, entitled Decent Living Energy, quantifies the material requirements and energy needs for eradicating multidimensional poverty around the world. His research interests also include investigating income inequality, compound vulnerabilities to climate change, and climate policy analysis. His methods include household energy modeling, econometrics, input-output, and policy analysis. His work has been supported by the European Research Council, National Science Foundation, Environmental Protection Agency, and many other organizations. Dr. Rao is also a senior research scholar at the International Institute for Applied Systems Analysis. He received his PhD from Stanford University in Environment and Resources, master's from MIT in Electrical Engineering and Technology Policy, and an AB from Dartmouth College. Please give him a warm welcome.
Thanks, Sam. Hi, everyone. Thanks, Anne, for inviting me. So yeah, household interest in energy transitions. So I guess I can say that I'm cautiously optimistic that we're on our way towards a net zero society. Although we have a daunting task ahead of us and there's a big disconnect between where we need to go and where we are. There's laws that are in place in sort of key emitting countries, and we have targets in place. So there's some optimism there. But there's a lot of interest among government agencies and policymakers and researchers to understand how households will be affected by the energy transition. And there are many pathways by which households will be affected. There's livelihoods and jobs from switching over energy supply. There's general price impacts propagating through the economy as we have various changes. But one important pillar of the energy transition is the electrification of households. And so that involves the adoption of new technologies by households. And of course, we're very interested in figuring out how can we develop incentives for people to rapidly get on board this energy transition. We're talking about households across the world in various contexts. And so there's a lot of research that's been done to get us to this point in understanding technology adoption, but a lot that needs still to be understood. So what I'd like to do is really make the proposition or give you the sense of the amount of research that we still need to at the household level. So we need more people-centered research. And I want to present some of the barriers that we face. And it's really time for us to do much more systematic data collection to really be able to understand some of the barriers and opportunities for households to really get on board this transition. So I have 3 research vignettes I want to present, various stages of completion, 1 in India, 2 in the US, 1 of them on heat pumps. And I hope to try and sensitize you to this issue of the need for more data collection in these areas. So first, to give you a sense of the scope of household electrification and the overall energy transition, I find it useful to take a look at the IPCC's Chapter 5, which is a new chapter on demand. And they've quantified the extent to which we can reduce emissions from demand-side measures. So there's a broad range of measures, of course. They have to do with fundamental lifestyle changes, sociocultural factors, some changes in how we use infrastructure, so for example, shifting modes of transport. But then there's a big chunk here on end-use technology adoption. Yeah? And that's essentially the electrification of transport and buildings. And the overall electrification of society and households in particular are going to involve a significant increase in energy demand that we also want to mitigate to the extent we can. So I'm interested specifically in that, household technology adoption. So with regards to transport, we all understand electric vehicles, but there are different types of electric vehicles. We could be talking about public transit, the electrification of bus systems, for example. In poor countries, we're talking more about two-wheelers rather than cars. And we have adoption targets such that we want to increase sales to 100% to EVs by 2035 approximately. And you're already seeing in the news today that there's been a politicization of EV sales, with regards to union workers and the impacts in automobile factories of shifting over. So understanding how people are affected by these various factors is important. In some parts of the world where scooters are being adopted, it's almost like the scooter is a household appliance. It's a new household appliance that's being added. And the amount of electricity that's going to be consumed in those households would increase by an order of magnitude from adopting these technologies. Then we have the homes. And in cold countries, switching over heating from fossil fuels, gas and oil usually, to electricity is a central strategy for building electrification. So electric heat pumps are effectively air conditioners that can run in reverse in order to provide heating. Electric stoves are really important technologies. So we have over 2 billion people today across the world that are still cooking with solid fuels that have significant health impacts and other issues. And currently, liquid petroleum gas is a good go-to technology, but it has a lot of issues too, including air pollution, and it's fundamentally a fossil unless we can decarbonize the gas production. So again, a lot of people are looking to electric stoves as a way to switch over. But here too, we would have a significant increase in electricity use in poor households. We also have electric grids that are already stretched in these countries, and to increase demand so significantly would impose a significant barrier as well. And then from the electrification of the economy in general, we're expecting a very large increase in electricity demand, which requires the grid to be grown and reinforced. So there's a lot of research on how we can be more efficient about how we grow the electricity grid. And so there's a lot of research into making us smart consumers. So using the internet to control devices that would be able to shift our load, maybe even reduce our load with certain incentives. It's possible that utilities would control household devices to be able to manage load from a system perspective. But that involves a lot of changes on the part of households in terms of adopting to these new technologies. We also have, of course, rooftop PV. We are becoming producers of energy and selling electricity back to utilities. So all of these changes involve quite a different way of leading our lives. And will people really want to adopt these new forms of managing energy in their homes? And what incentives do we need to make them do that? Even in poor countries where people are getting access for the first time, while in the past they'd just get a connection and just use appliances, now they're getting electricity from a solar panel and a battery system, and that combination has to be managed. And if they don't have the information to be able to manage that or the services to be able to keep up with them, they might not be interested in using that. There's also issues of scaling them up as incomes rise. And so the adequacy of these systems and the ability for households to engage with them is also a big question. So there's all of this. So this is the scope of technology that I'm interested in, but I'm going to focus on heat pumps and stoves. Now, just to give you a sense of what we understand and what we don't. So, speaking with a broad brush, we know from social science research up to now, there's been a lot of research on behavioral economics and sociology and psychology, where we understand to some extent the factors that are driving the adoption of, let's say, home improvement or technologies in the home. But most of the research so far has been largely around end-use efficiency improvements, with some growing amount in EVs and PV, rooftop PV as well. And of course, economics are the fundamental driver, the cost of technologies, but there are other behavioral aspects, cultural and social aspects, cognitive and behavioral issues. So for example, people have inertia, people don't have information about the various benefits for different devices. They may not trust government and engage in policies because of that distrust. Physical conditions of their homes may make a difference as well. I'll talk about that later. Actually, the cultural factors, I'll give you an interesting anecdote. Many years ago, when I was first getting into this, we were looking at the adoption of white goods, so washing machines, refrigerators, and televisions in India in household surveys. And in that statistical analysis, I discovered that certain parts of North India, there was really high penetration of refrigerators, out of the ordinary levels of penetration. I was curious as to why that was the case. And it's definitely statistically significant and apart from what we found in other parts of the country. And I went back and I presented this work in India. I spoke to different people. It had to do with the fact that in that part of northern India, they really liked dairy products. And it was to the extent that in commercial establishments in villages, they would buy washing machines and use them to churn milk to make buttermilk. And I mean, that was the extent to which there was an interest. And so we actually picked that up in the data that there was a higher penetration of refrigerators controlling for income and other factors. So that's the kind of thing. It's nice that we picked it up in the data, but there's a lot of other factors that probably we don't understand that influence uptake. Okay, besides barriers, there are also opportunities. And as we've seen with COVID and green recovery, when there's a big infusion of investments from the government, we think about how can we piggyback on that other benefits. So we're thinking about how we can make a green recovery, right? In similar vein, we know that there's a lot of conditions, existing conditions that we'd want to alleviate. And if we're going to invest in end-use technologies, then maybe we can piggyback on that with incremental costs that are not significant, investments that can have disproportionately high benefits to people's quality of life. So we know there's a lot of benefits of air pollution reduction, but housing quality. So if you're going in there, providing investments in heating technologies, households sometimes have poor construction quality. They may have mold because they don't have air conditioning. If we were to make upgrades to the home overall, then you can have a significant improvement in people's lives. There's climate resilience as well. So heat pumps can operate also as air conditioners. So households that don't have ACs but get heat pumps for heating get a free cooling device. And so this is a form of climate resilience potentially as well. It's interesting, consumer sovereignty. So there are certain tribal lands in the US. I had a master's student investigating that people were not interested in grid connections, that they've been rejecting grid connections for a long time in certain tribal lands. But they've been embracing solar rooftop PV systems because it provides them with more autonomy and control over energy resources. They have households that today don't have cars in the US, and that lack of mobility affects their lives in various ways. And so if we have e-mobility options that are introduced, it could provide significant benefits to meet other needs of theirs besides just providing them with energy services. So we need to have a better understanding to maybe quantify these benefits so we can perhaps provide more incentives to people to take up some of these technologies. Okay, so that's a broad overview of some of the barriers and opportunities that we want to be able to understand better. Now I want to go into each of my research vignettes. The first one concerns electric cook stove adoption in India. This actually started out as a master's thesis project of a student of mine, Amalta Gupta. And it was a small pilot, but the results from it are interesting enough that I'm continuing with it and hoping to actually scale it up and maybe get funding for a more systematic study. But I found this to be insightful in ways that I wasn't even expecting. So the concern here is that we, of course, have plenty of people who need to get off of solid fuel stoves all around the world. It's a daunting enough problem that we want this to happen in the next 10 years. Probably won't, but the point is to accelerate that process. The significant public health benefits, among other things. It actually also contributes so much to climate change, to short-term climate forces, that shifting over to fossil fuel, gas, is actually going to have a negligible increase in emissions compared to what you get just from inefficiently burning biomass. So it's not so much a climate contributor, but in the long term, we want it to be completely decarbonized. So shifting to electric stoves, where electricity is zero carbon, is kind of the way to go. And we want to investigate, will people adopt these stoves considering the electrical conditions, considering the cost, and other factors. Now, in past work, we already understand that affordability is really important, and we've done analysis of price points where people would switch to cleaner stoves. And when you have volatile price increases, people switch back to using solid fuels. So we have an understanding of the economics, but there's other factors that may influence people's continued sustained use of these stoves. So in the past, people have tried for decades experiments with new kinds of stoves, but people haven't sustained use of those stoves. So we wanted to ask, if we were to give people these stoves, let's say we made them cost neutral. So we provided them with a free stove. We provided them with the pots that you need to use for induction stoves. So you need stainless steel or ferromagnetic materials. We provide them with that. And then we would monitor them over time to find out if they would actually use these stoves. And so we did that. We chose 60 households in a part of Maharashtra. I'll talk about the sampling a little bit because that was the interesting part. And we gave them these stoves. But very interestingly, we didn't want to rely on sort of customer recall in terms of understanding what their usage of the stoves were. So we actually had little meters made that would measure in a 15-minute increment the voltage and the current when they were turning the stove on and off. So we could actually measure the usage of the stove over those 4 months. And we monitor these households over the period of 4 months. And we're in the middle of looking at the results. Like I said, master's students graduate and leave us with a trove of information to work with. but this is all good. It's all very good. So we have here an illustration of the use of the stove in terms of for every hour of the day averaged over the 4 months, the pattern of usage over the 60 households. And so what you see is the bulk of the usage of the stoves is in the morning time, actually, and not during lunchtime or evening time, although of course you have that too. And the puzzle was, why do you have this really high amount of time spent in the mornings? And we found out that one of the main uses of this new induction stove was for boiling water. So they continued to do their cooking with their chulas, as we call it, the biomass stoves, but they discovered that actually these stoves are very efficient. And cooking water is a really important part of people's lives. And in fact, from an energy perspective, it's the most energy intensive part of cooking. And they use water for ablutions. They use water for tea and for cooking. And in some cases, if you have animals, you actually in winter want to warm the food for animals. So the amount of water usage is actually quite significant. So even if people don't transition completely to electric stoves, if they were to do so just for water usage, actually that would alleviate a large part of the problem. So that was an interesting finding. One of the reasons we wanted to do this study was to investigate whether electricity reliability would influence their usage. Because as I said, we have stretched grid conditions. So we actually selected villages with different levels of reliability from what we understood a priori. And we did find in one village more than the other, they have outages much more often during times when they prefer to cook. So we are in the process of figuring out how much did that really impede their usage? Do we see a statistical effect of that? Or were they just happy to shift over their hours of usage to another time, for example? So that's what we're doing. It's teaching us a lot of insights, but probably the most important insight from the study was what we were not expecting. Was when we were sampling these households for the study, we found a lot of households, it was completely unsuitable for them to have cook stoves because the electrical conditions inside the homes were completely unsuitable in various ways. So there were safety issues. Do they have earthing when you introduce such a high voltage appliance? There's safety concerns, but also households are sanctioned a certain amount of capacity based on their connection. And in some cases, the electric cook stove would increase that sanctioned limit. So you have to have changes at an institutional scale to be able to accommodate that level of appliance. And people aren't thinking or talking about these electrical conditions inside homes as a barrier to energy transitions. And it's something we need to investigate. So I'm trying to now do a much more systematic study of specifically this. What are the barriers for adopting new appliances just with regards to the internal electrical conditions? Okay, to my next story. This is about heat pumps, the heat pump adoption in the US. So here, the point I want to make is we have limited data. So what we've tried to do is try to squeeze out as much as we can from existing data sets, so nationally representative data sets, to see what can we tease out about the drivers or determinants of people adopting different kinds of heating appliances. So we set out to look at a particular survey, the American Housing Survey, to understand what are the social and economic drivers of heating appliance choices. So taking a look at a cross-section of households and what existing appliances there are. Taking a look at a number of drivers such as social context, fuel prices, of course, costs of heat pumps and other heating technologies, and then statistically try to find out what's the probability of a household owning one type of heating appliance versus another based on these determinants. And then we use that information to predict heat pump adoption by 2030 in New York State. This project was for New York, based on the incentives that were provided for heat pumps and the Inflation Reduction Act. So the methodology was statistical analysis, we developed a sort of a choice model based on the American Housing Survey that gave us estimations of the influence of these different factors on the existing appliance ownership. And then, and this was an innovative part, we applied those predictors to the households in the American Community Survey, which is a much more extensive survey that allows us to look at the conditions of about 75,000 households in New York State, expanded to include some of the conditions that are not in this survey, but in the American Housing Survey, and then applied the predictors from our estimation to quantify how many people would adopt heat pumps under different levels of subsidies in New York in 2030. So first, I want to show you what we found to be some of the influential determinants of heat pump adoption. So this is the marginal probability of owning a heat pump. And it turns out that younger households tend to be much more likely than older households, head of households. Bigger houses, people living in bigger houses are more likely to adopt heat pumps. The number of household members didn't matter so much. And here's an interesting insight. Once you control for these other factors, income didn't seem to be important. And this is consistent with some other studies recently that have also found that the adoption of heat pumps does not seem to be dependent on income once you control for other factors. It doesn't mean that income doesn't matter. It does, but things like the size of your house depend on your income as well. So when you control for some of those factors that do reflect differences in income, it seems that the margin effect of income is not so strong. And then we found other sort of correlates, shall we say. Urban households were more likely. We found this phenomenon that Hispanic head of households were less likely than others. We don't know why. These are obviously proxies. And because this is a statistical analysis, there's something about those households. It could be their physical conditions. It could be cultural habits. We don't know. Also, houses with better insulation and in warmer climates, so more in the Long Island area, were more likely to have heat pumps than those in colder climates. So this is all intuitive, but these are all, in some cases, proxies. We don't fully get what they reflect. But it's the best we can do from the data. So we had a pretty creative way of then inferring from that analysis the willingness to pay for heat pumps. So basically looking at if you change the prices of heat pumps, at what point do people switch to selecting the heat pump as the most probable option? And we discovered a real high heterogeneity in people's willingness to pay for heat pumps. There is a relationship with income, so at higher incomes, people are willing to pay more. But this heterogeneity also gives pause in terms of the kinds of policies you have and how targeted they are, right? If you have just blanket opt-in policies, you may not have as much uptake as you desire. So using these estimates of willingness to pay, we assess the Inflation Reduction Act incentives. And assuming, again, people have perfect information and ignoring some of the potential costs that they have inside their house, which we don't have in the data, we estimated that there would be a pretty high willingness. About half of New York households with the IRA incentives would be willing to adopt heat pumps. But the interesting thing is, the subsidy that would be required based on their different willingness to pay would be a total of about $32 billion. This is 3.5 times the amount of money the government has currently set aside, the $9 billion for home improvement in the entire US. And just for New York households, for half of them to adopt heat pumps would require 3.5 times that amount. And what's also interesting is that subsidy would not only be taken up by low-income households, it's a very progressive subsidy, much higher for low-income households, but we would need to increase it for even middle-income households who have a much lower threshold for how much they need to get as a subsidy to adopt a heat pump. So it's also interesting about how we need to distribute the subsidy across different income levels. We found a slight trade-off between progressivity and sort of equity and efficiency in terms of the bang for the buck you get in terms of emissions reductions from an investment of policy. Okay, but this analysis didn't allow us to capture many other constraints. So for example, I was talking earlier, in the Northeast US, we have households that have much higher switching costs because their internal distribution system may not be forced air for heating. They use water distribution. And the technology in the US doesn't exist commercially for air-to-water heat pumps. And so there would be much higher internal costs. Also, the analysis we didn't actually observe the choices people made for adopting a heat pump. We just looked at existing ownership. Now, it turns out from a more recent version of this data set, the American Housing Survey, they track households over time. So we can look at households that adopted heat pumps in the last few years and look at their prior conditions from earlier versions of the survey, and then find out what extent did prior conditions have an effect on their choice of heat pumps. That's kind of interesting. So what furnace did they have before? What kind of distribution system did they have? And how does that influence the uptake of heat pumps? And we're still analyzing the data. This is more descriptive analysis. But the first thing to understand is where people have adopted heat pumps. It's largely, this is metropolitan areas. In Phoenix, Miami, LA, in warm areas of the country is where most of the new heat pumps that have been adopted exist. And we wanted to look at how it relates to their prior conditions of their heating system. And it turns out that over 80% of households that switched compared to those who didn't switch had central air. But interestingly, only 38% compared to 70% who didn't switch had forced warm air furnaces. So it seems that central air is a more important determinant than having a forced air warm furnace. But in both cases, the point is they have ducted air distribution systems, which seems to be really important. So this is just descriptive. We still have to tease out statistically what the influences are. But this seems to confirm a little bit of our hypothesis about the existence of this forced air system. But the fact that it's driven more by central AC than by gas furnaces was kind of interesting. Okay, that's work in progress. And now on to my third story. So now I want to move more to the benefit side. We investigated a little bit more barriers in the last two cases. And I want to present a new data set that we've created, again, with the intent of trying to extract as much as possible what we can learn from the data that already exists. So that I think you're all familiar with the Justice 40 objectives now of the Inflation Reduction Act, which is try to channel 40% of the benefits of federal investments to disadvantaged communities. And the question is, who is disadvantaged and how do we define disadvantaged? So what are the benefits that clean technologies can bring to alleviate some of these disadvantages? And we have a very limited understanding at a granular household level of conditions that might influence these benefits. So the EPA, for example, in its report about the Inflation Reduction Act and its implications, has stressed that we need to strengthen the scientific foundation for assessing cumulative impacts. So they are partly referring to the impacts of environmental stressors. So where do we have households that are facing extreme heat risks combined with being next to a power plant that's emitting pollution or next to a hazardous waste site, and where do we have those overlapping vulnerabilities? But there's also social vulnerabilities that matter. So where people have high energy burdens, high energy security, or where they have other kinds of burdens such as high mobility costs, transport costs that may be alleviated with the introduction of new types of technologies. And so identifying these overlapping vulnerabilities at the household level, including both environmental stresses and social vulnerabilities, is not possible with data that exists today. Because in household surveys, we generally have these metrics separate in specialized surveys. We don't have them combined at the household level. And currently, practices for screening households in the process of defining disadvantaged communities tends to use these separate surveys and just overlay, so percentage of households who have this hazard, percent of households who have that deficiency in income poverty, all on top of each other at a broader geographic scale, with just a rough approximation for whether people are actually facing those vulnerabilities together. So our goal was to try and take all of these data sets and create a data set that would actually allow us to look at least estimate those vulnerabilities at the household scale. So it's Fusion SES. We're calling this data product Fusion SES. This was supported by the EPA. And what we've done is taken the American Community Survey as a base. We have fused in all of these different household surveys. Now, the American Community Survey is a survey with over 2 million, depends on the year, but it's in the order of 1.5 to 2 million respondents, compared to the specialized surveys that are on the order of thousands or tens of thousands of respondents. And so we are imputing to the ACS some of the variables in these specialized surveys so that we have like an expanded view of the American Community Survey that reflects all these different attributes of household consumption. And the way we did this was using machine learning algorithms. We looked at matching the American Community Survey with each of the donor surveys, coming up with a set of shared characteristics, and using that shared characteristic set as a basis to estimate the probability of how people would answer the question in the specialized survey in the American Community Survey. So it's coming up with sort of a synthetic data set that has estimations of how people would respond to what's your energy burden, what's your mobility burden, what's your consumption expenditure profile for 1.5 million respondents as opposed to 10,000. And this is at a granular scale at the county level approximately. So this allows us to now look at these cumulative burdens at the household scale. Of course, it's statistically estimated, and we have uncertainty bounds for them. But we have the ability to then take the ACS and then downscale it even further with some estimates of uncertainty. So we can start to think about where do we target investments in specific sectors and what kind of impact would that have specifically on people in different geographic locations. Just to give you an example. So currently, we look at energy burdens in terms of how much money people have spent or as a share of their total income. But there's another form of energy insecurity where people don't spend money because they can't afford it, so they forego services. So we call that energy insecurity. And that correlates very roughly to energy burden. So the same household may be experiencing both, but it's not a perfect correlation. And so if you look at households that are experiencing both high energy insecurity and high energy burdens, we find them located in these areas. Okay, but let's look more closely. If we look among those households, some of them we may say are households that are choosing to maybe spend more money on energy so that they don't have the energy insecurity. But there are other households that may in fact decide to forego other services. Decide to sacrifice energy services in order to meet other services, like the heat versus heat dilemma. So people may be sacrificing other services in order to get the level of energy service they want, but other households may do it the other way around. And you see that there's different households that are in these different categories. So this level of understanding we wouldn't have had just looking at the energy consumption survey because it's too high at a geographic scale. And so we're able to do this with the ACS, so we can maybe identify specific areas we want to target policies. We've done more with this. We've merged these data with well-being surveys. So Gallup asks people, 1,000 people a day actually in the US over the years, how satisfied are you with your life and how satisfied are you with various different aspects of your life? Very detailed questions. And we wanted to ask, well, if you have these different deprivations that we are capturing in these surveys, what do you say about the quality of your life? What do you say about how satisfied you are with your life? And how can we relate these deprivations to your assessment of life satisfaction? And we found quite distinct differences in people's life satisfaction scores at all income levels for these different kinds of insecurity. So here I'm talking about energy insecurity, housing quality, mobility, insecurity, and food insecurity. And each of these dimensions, we are finding people's own assessment of their life satisfaction is statistically significantly lower when they face these insecurities. And the more of them they cumulatively face, the more significant their reduction in their assessed life satisfaction. So that's kind of an interesting way to look at insecurity from people's own perspective, which is kind of important. And we couldn't actually address that before. Okay, so what's the use of this data set? Yeah, there's numerous policy questions we want to answer with this. I just want to give you a couple of examples. One of them, EPA itself, one of the reasons they commissioned this work was they have a macroeconomic model where they're trying to estimate what the distributional impacts would be of different energy policies. So they've just come out with a draft paper on the distributional impacts of the Inflation Reduction Act. And this data set allowed them to create what they call a micro simulation that is translating macro effects of the policies to households at a much finer spatial scale than they could otherwise. And so they have the effect on different racial groups, households of different education levels, male versus female, 4 different scenarios of policies, but at a scale that they couldn't before because of this data set. I'm interested in looking at extreme heat vulnerability. So right now, we're analyzing these data to find out who's vulnerable to extreme heat. So we do know in the US that over 90% of households have air conditioners. But interestingly enough, if you look at households that can't use the air conditioner because either it's been disconnected or it broke down, there's a small share, like up to 1 to 3% of households in, again, these same culprit areas in the South and Southeast that have air conditioners, but for a certain amount of time don't use them. Further, there's another question that's been asked in the energy survey, which is, do you have your household held at an uncomfortable temperature? Is your home at an uncomfortable temperature? So households that have air conditioners, they use them. But again, going back to the energy insecurity, because they can't afford, they don't cool their households to the level they want. And so you have insufficient AC use, or people are sacrificing other services in order to use the AC to the level that they want. And there's a lot of households in that category, again, in these areas. So these kinds of granularities is what we're trying to pick up. And now I want to investigate how we can use heat pumps potentially to alleviate some of these insecurities to the extent that it does provide a cost-effective way to do that. So that's one potential use of these data. Okay, so that's where I am. Overall, I wanted to give you a sense that we need more systematic data collection about households because there's a lot of heterogeneity in people's conditions. We need new and better data. The existing household surveys that we have are useful, but they don't capture a lot of information that we need about people's decision making. A lot of the research that I talked about that we have up to now, they rely on small sample surveys that are conducted in particular parts of the world, such as in Europe, actually predominantly, more and more in the US. And so they don't produce generalizable enough results necessarily that we can then use to systematically better project household adoption in our models, for example, or just have systematic insights about how to direct policies towards particular groups. And so we need more of that data collection. To the extent we're capturing benefits that are non-economic, we need to incorporate, well-being metrics that are not just economic costs. So, for example, New York State is considering, in addition to a carbon price, a pollution damage cost that they want to also include. So environmental justice stakeholders are trying to push for that as well. And ultimately, we want to also include climate feedbacks because some of these technologies can actually provide some sort of resilience to some of these impacts, as I mentioned, with heat pumps, cooling, and extreme heat. And I've have my vision for where I think we want research to go in trying to center households and looking at consumption behavior and the different influences in terms of social context, cognitive and behavioral factors, the built environment. This is all kind of pushing for more interdisciplinary research that's trying to incorporate insights from the social sciences into our quantitative models that are being used to project energy demand in the future and climate emissions in the future. And then ultimately also looking at the feedback onto well-being of these different pathways on people from the energy transition. So that's what I leave you with. I'm using the work of several of my lab members, and I thank them for it. I also have some external collaborators and want to thank my funders for this work, which is all very ongoing work. And yeah, I look forward to any questions that you have. Thanks. Great, all clear.
Okay, yeah, thank you so much for your talk. I have a question on the relationship between insulation and heat pumps, because I know that at least in the UK, I remember there was lots of talks about like fabric first or like heat first, and so there was a big push to like insulate buildings first because there were bad case studies where heat pumps were put in and then they weren't performing right, and then that had like bad public press for them, and so it was. Yeah, and just if you see the same thing over here or not.
Yeah, I mean, we were just talking about this earlier. If you go to contractors and ask them about what I should retrofit my house with, and if you look at a household that has very, very leaky shells or windows, and they discourage you from making a major upgrade to your housing equipment, and they prefer that, why don't you do it all together? Or it may be more cost effective for you to combine improving your building shells to improve the efficiency of the home, and then change your heating appliance as well. But I don't think it should necessarily be a barrier for investing in a heating appliance, because the heat pumps have a significant efficiency advantage. And so in some ways, you can think of those as alternatives for trying and reducing energy usage and carbon emissions if you have limited resources. But unfortunately, it is the case that today, homes that have better insulation, we even picked it up in that research, are showing a higher likelihood of adopting heat pumps. It could mean many things. It could mean that they were more inclined to making investments in the first place, so that's why they are. But it doesn't necessarily mean that the economics of heat pumps are improved by doing that. It just happens to be that people are being encouraged to look at the entire package together, which makes sense, But I do think that the justification for heat pumps exists without necessarily looking at the building shell conditions. Arjun?
Yes, my turn. Hi. Yes, thank you. I'm interested in the relationship between the use of electricity to boil water in India and the availability of clean water. Are they boiling water to sanitize it so they can use it or so they can drink it? And that would apply obviously to many other areas in the world, particularly Africa. So my question is, this may be a project for the future for somebody at the school here, exploring the dichotomy between a government entity sanitizing water and distributing it, as opposed to having it sanitized at the household level, using electricity, or if it's not available, fossil fuel.
That's a really interesting question. I can't say I have a definitive answer to that. There are many alternatives to water purification that are currently being used. So you have water filters that also could be an option for households. And what would be, so one question is, what is the right strategy for providing potable water to people, right? And that debate we even have over here, where people utilities spend millions of dollars to provide potable water to people in the distribution system. And yet you have people drinking out of plastic water bottles. So that question about, in a country like in sub-Saharan Africa or in India, what's the best strategy, the cheapest strategy for providing people with potable water? I don't know the answer to that, actually. It would be interesting to look at whether filters versus boiling water versus distribution systems are better options. But in a lot of cases, you wouldn't have the option of distribution systems. If you have highly decentralized populations, you ultimately will look for decentralized solutions. You still have the question of filter versus boiling water. But now going to the cook stove benefits, from what I understand, regardless of electric cook stoves, right, people have been boiling water with other technologies. My understanding of the literature, people are not being motivated by that. They're not boiling it. You have to boil water for a good 20 minutes, if you really want to kill all the bacteria. And I don't believe, from my understanding of the literature, that's what's driving there. It's just hot water for bathing and for making tea and generally for cooking. Whether it's motivated specifically for making it potable, I don't believe so, but it could be the case as well. Arjun, and then Alison next.
That people are also that study based on the reliable access to there was there is different. So while there is a lot of also investigating what right but it is also a fact that those behaviors are made by the large norms that they are operating. So then how do you tease out the difference whether choice has been speaking to the like individual choice or if it is more of a choice about something within the larger whether it's a choice or that you're operating. Especially when you have to do that. Because you can find certain patterns that are one, but that cannot be translated to another. Like you cannot be like then it becomes difficult to say that the same from a pattern to
Yeah, actually, I just wanted to show you. I don't know if that was me who did that. Anyway, that figure that I had showed at the end of my presentation is very much about trying to capture social and contextual factors. Some of those may be structural constraints in the system, like the electricity conditions, very much distinct from perhaps behavioral factors. And I think one can capture that if you have extensive data collection and sufficient data power to be able to look at households with particular conditions, controlling for those conditions and then examining behavior. You could tease out, there's no reason why you couldn't try and separate those factors. And there's a lot of research in sociology that's talked about behavior that's influenced by socioeconomic conditions in society. That's how your values are shaped. That's a more difficult question. You know, how do you look at the influence of a general life on your values? And this is like the social practice theories and coming out of the UK have these, you know, that there's no individual agency. It's all about social norms. And then the question is, well, that's very hard to capture because then where is the locus of change? But we do have an understanding of those distinctions. I think it's possible to tease out those factors separately, but we just need more data, more granular data to be able to have the statistical power to control for them. And you can also work with much more sort of qualitative research to actually understand, ask people and talk to them and figure out what drives their decisions. Yeah. Alison and then Nat.
So we have some questions that were asked from our online attendees. I'll ask one. One attendee said, I would be interested in looking a little deeper at the correlations between life satisfaction and different burdens. And they asked which burdens are the most significant, and out of these burdens, which could a small decrease result in more significant satisfaction, or would they all decrease the same?
Yeah, at this point, we've done only descriptive analysis. It's hard to say which ones. So from the 4 that I showed you, so energy, food, housing, and travel insecurity, just from our initial statistical analysis, the energy insecurity turns out to be the most influential among those burdens on life satisfaction. But what's interesting is that the order of magnitude or the magnitude of the effect of those deprivations on life satisfaction are significantly less than the effect of social factors like being married, being divorced, things like that have a much higher influence on life satisfaction than these insecurities. But among them, energy insecurity seems to be the highest.
Thank you so much. Quick question about the slide you presented on where you found that if 54% of New York residents were to adopt heat pumps, it would be astronomically more than what was allocated for the Inflation Reduction Act across the entire United States. I'm wondering if that figure takes into consideration like weatherization costs and pre-electrification work, in addition to the cost of maybe installation and the equipment. I know that for a lot of like heat pump pilot programs at the community scale or neighborhood scale, a significant barrier to project implementation is the cost of pre-electrification weatherization. So I'm curious if that's why that cost is so high, or if it's primarily just the cost of the equipment and the cost of the installation.
Yeah, it does not include those costs. So it's an underestimate, in fact, of the subsidies that would be required. And that's why the subsequent work that I'm doing using the panel analysis, we're trying to incorporate into that some of these costs that were not there in the survey. So we're externally bringing in switching costs for different types of household conditions, including what kind of forced air system they have and what retrofits they need inside the home. So yeah, absolutely, that was an underestimate. Matt?
And those that actually like have the highest marginal benefit to well-being or satisfaction, and look for win-win ones that are not like these are the ones that are most efficient for reducing emissions, but also making people better off. And you have kind of like a systematic way to kind of make comparisons across different interventions.
Yeah, that would be nice to be able to do. So the unfortunate thing about these Gallup well-being surveys is you have a lot of data points. They ask 1,000 people a day, every day, when you have the data for 10 years. But it's not a panel. You don't have the same households that are asked every time. So you have to look cross-sectionally. And so then you can, using whatever techniques you can to try and look at policy shocks at particular times and try and see if you can find out the effect of a policy shock on people's well-being before and after. But again, you'll be looking at cross-sectional data that wouldn't be the same households. So whatever limitations there are with using cross-sectional data, yeah, I think that's what I'd like to do to some extent. The first stage is not looking at the policy interventions, but just looking at the conditions that we consider to be potentially deprivations, how they relate to life satisfaction. And the next stage is, can you identify particular policies that may have had an effect of relieving particular insecurity, and how is that affecting life satisfaction? That would be the next stage. Yeah, I hope we can do that kind of analysis, but that is definitely what I'd want to do with this. Run out of time. Yeah, right.